So problem number 40. The question is solve the inequation and represent the solution on the number line. You have,
Sir, please do the sum number 41.
yes, I'll
Good
do
morning, sir.
after this I'll do. Good morning. Minus 3 plus x less than or equal to 8x by 3 plus 2 less than or equal to 14 by 3 plus 2x, where x is an integer. Okay, so replacement set is the set of integers, and you need to solve this inequality. So the x can assume only values that are integral. Okay, only integer values x can accept. So let's see, this inequality can be split into two. Minus 3 plus x less than or equal to 8x by 3 plus 2. This is the first one. And the second split is 8x by 3 plus 2 less than or equal to 14 by 3 plus 2x. Both the inequalities will solve separately as we have been doing. So take the x's together. You have 8x minus 8x by 3 is less than or equal to 2 plus 3. Now if you take the LCM here, you get 3x minus 8x by 3 less than or equal to 5. And here you have minus 5x by 3 less than or equal to 5. That means now multiply both sides by plus 3. So minus 5x by 3 into 3 less than or equals equality. The inequality sign will not change. It will not reverse because we are multiplying by a positive number on both sides. So here we are left with minus 5x less than or equal to 15. Now we need to make the coefficient of x 1, which means we need to divide by minus 5. We are dividing by a negative number. That means the inequality sign will reverse itself. That means x is greater than or equal to minus 3. This is the solution for the first one. Okay, so write the solution set. Say solution set A is x such that, or this is a finite set, infinite set actually. But anyway, let's write it in the tabular form to look a little easy. So x is an integer. Replacement set clearly is an integer, right? Is a set of integers. And what integers are greater than or equal to 3? Minus 3. It is minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and so on. This should be your solution set in tabular form. If you want to write it in set builder form, you can write it in this manner also. X such that x greater than or equal to minus 3, x belongs to I. Okay, this is in set builder form. Next we solve this inequality. 8x by 3 minus 2x less than or equal to 14 by 3 minus 2 means 8x minus 6x. is less than or equal to, now take the LCM, 14 minus 6 divided by 3. 8x minus 6x is 2x divided by 3, less than or equal to 14 minus 6 is 8. Multiply both sides by plus 3, you get 2x less than or equal to 8. Okay, divide both sides by plus 2, you get x less than or equal to 4. The inequality sign did not reverse here also, it did not reverse here also. Reason, because we multiplied both sides by a positive number in this step, and in this step we divided both sides by a positive number. That is why the inequality sign did not reverse. So now let us write the solution set. B, the solution set is x. Um, in fact, x is an integer and it is less than or equal to 4. So all the from minus infinity, you will have all the negative integers, and you will have minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. This is your uh, solution set. You want to write this in set builder form, x such that x less than or equal to 4, x belongs to I. Now the solution set of the inequality, the the given inequality here will be the intersection of these two sets. Okay. So what is the intersection be? Therefore, solution set of the given inequality is A intersection B. An intersection of what two sets? Minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and so on. This infinite set, the intersection of this set with another infinite set, which is, okay, these two infinite. What is the intersection of these two infinite sets? The common elements, minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4, right? This is your um, solution set. Do you agree or not? Anyone who does not agree, graph it on the number line. Now when the set is in integer, you graph it in this manner. You simply put dots over numbers when the set is an integer. Only in the case of real numbers, the problem happens that you have to put your arrows, because your solution set mostly comes out to be an infinite set in the case of real numbers. Now am I mostly? In fact, in all the cases, it comes out to be a infinite set. So let us now mark. So you have a minus 3 here, a minus 2, minus 1, 0, 1, 2, 3, and 4. So that is how you represent your uh, solution set on the number line. Okay. Any questions? Let us see next one. Find the greatest integer which is such that
Yeah.
if 7 is added to its double, the result is a number, the result, the resulting number becomes greater than 3 times the integer. Okay. Find the greatest integer which is such that if 7 is added to its double, you double the number and add 7 to that number, the resulting number, that is the number that you get, is greater than 3 times the integer. So I say let the integer be x. Okay. Now it is said that uh, find the greatest integer such that if 7 is added to the double, 7 added to double the number is what? 7 added to double the number is 2x plus 7, right? You double the number from x to 2x and then add 7. Okay. So find the greatest integer which is such that if 7 is added to its double, so we have added 7 to double the number. The resulting number, that is, what is the resulting number? 2x plus 7. The resulting number becomes greater than 3 times the integer. So according to the problem, resulting number becomes greater than 3 times the integer. This is what is given according to the problem. So what is the resulting number here? 2x plus 7. And the integer we had taken as x. Now we solve this inequality. And remember, what is the replacement set here? It is a set of integers because see, we have taken x to be an integer. Now we solve this inequality. So you have 2x minus 3x is greater than minus 7. And you have minus x is greater than minus 7. Now in order to find x, we have to divide both sides by or multiply both sides by minus 1. In either case, the sign will change. So x is less than 7. Now x is an integer such that x is less than 7, and you have to find out the greatest integer. So which greatest integer is less than 7? Therefore greatest integer less than 7. Tell me which greatest integer is less than 7. Anyone?
6.
6. Finished. That's the answer.
Six.
Any questions on this problem?
No, sir.
So that's it. I conclude this chapter here and I move on to AP, arithmetic progression.
Sir, GP is not there in our syllabus.
Yes, GP has been excluded. Arithmetic progression. Your classwork copies need to be updated till the whatever I am doing today. Okay. Whatever I am doing today, till today, your classwork copy needs to be updated. Arithmetic progression. Now, what is a progression? Actually, progression is a sequence. Okay. Any sequence is called a progression. Sequence and progression. These are quite synonymous. They differ only very slightly. Okay. Any sequence is called a progression. Now, what is a sequence? Any set of numbers, remember. Any set of numbers is called a sequence. So the keyword here is set. Any set of numbers. So it is a set. A sequence is nothing but a set. Any set of numbers is called a sequence. Okay. So now we have, um, suppose, now, but what about this arithmetic progression? Arithmetic progression is also called arithmetic sequence. Arithmetic sequence. Arithmetic progression is also called an arithmetic sequence. Now, as I told you, any sequence is nothing but a set of numbers. Okay. So let this be a set of numbers a1, a2 up till an be a set of numbers. Okay. Now I don't know whether this is an arithmetic sequence or this is a geometric sequence or whatever. I don't know. Okay. So what I do is, in order to check whether this is an arithmetic sequence, this set of numbers, which is this is a special set of numbers representing an arithmetic sequence. So what I do here is I subtract a2 minus a1, that is second term minus first term, and I subtract a3 minus a2, that is the third term minus the second term, and I see that they are equal. I I see that they are equal. When I see that they are equal, say, and both are coming equal to D, then we say that D is the common difference of the AP. We say D is the common difference of the AP. Okay. Once we have got this equal to D, then we can say that this is an AP. Previously, I did not know whether this was an AP or not. But once I subtracted A2 minus A1 is equal to A3 minus A2, and I saw that they are equal and both are equal to D, then I know that this is an AP. This must be an AP. Then I say that if this is an AP, then D must be the common difference of D. Okay, let us see an example here. So look at this set 1, 2. The set of numbers given here is 1/3, 5 by 3, 9 by 3, 13 by 3. This is just a set to me. Okay, this is just a set of numbers to me. Now the problem is whether I know whether this is an AP or not. So what I do here is this is A1, this is A2, this is A3. A1, A2, A3. Now remember, A1, A2, A3 are called the first term, second term, and the third term. Okay, this is called the first term of the AP. This is called the second term of the AP. And this is called the third term of the AP. Okay, and so on. This is the fourth term. And finally, we'll talk about the nth term a little later. Okay, the nth term, a general term, any term that you want to determine. So that is what the nth term will be. But right now, we talk only about the first, second, and third term, fourth term, fifth term, and so on. So this number, this is given. Okay, now I don't know whether this is an AP or not. So what I do is I subtract. So I say let A1 is equal to 1/3, A2 is equal to 5/3, A3 is equal to 9 by 3, and I start subtracting. Therefore, what is A2 minus A1? 5 by 3 minus 1 by 3, which comes to 4 by 3. Similarly, E3 minus E2 will be 9 by 3 minus 5 by 3. Okay, so it again comes to 4 by 3. So what you see is that A2 minus A1 and A3 minus A2 are both equal to 4 by 3. So here A2 minus A1 is equal to A3 minus A2 is equal to 4 by 3. So therefore, what should be the common difference? As I told you here, if both A2 minus A1 and A3 minus A2 both are equal to D, then we say that the common difference here is, therefore common difference is 4 by 3. And what is the next question? You also have to write the first term. First term here is A1, right? First term here is A1. What is the first term here? A1. It is 1 by 3. That's it. That's it. What did you see in this problem here is that a set of numbers was given. Okay, and from this you determine the common difference and you determine the first term. Okay, so in AP there are there are two basic kind of problem that can be given. The first basic kind of problem is that the set of numbers can be given. From that set of numbers, you have to determine the common difference and the first term. Okay, and the second type is when the common difference and the first term are given to you, and you will have to determine the set of numbers. Okay, so the second type is when when A1 equal to first term and D equal to common difference is given. Then how to determine the AP? How to determine the AP or the set of numbers or the sequence, whatever. Okay. Now in this, let us see if, with the help of this example, the next example, 2, 4. Let us see. The question here is find the first four terms of the AP. Now, before I move on to this question, let me just give you the rule of, in fact, the formula to determine, which I forgot here. Okay. When the first term and the common difference of the AP are given, then how to determine the set of numbers? The AP will be, remember this formula, please. The AP will be first term, A1. Then the second term can be taken as A1 plus D. The third term can be taken as A1 plus 2D. The fourth term can be taken as A1 plus 3D, and so on. We'll come to the nth term a little later. But for the time being, remember that if the first term and the common difference are given to you, then this is the way, this is the formula, or this is the way you will determine the AP. That the first term will be A1, the second term will be A1 plus D, the third term will be A1 plus 2D, okay, and the fourth term will be A1 plus 3D, the fifth term will be A1 plus 4D, and so on. Okay, so coming back to this problem here. Question here is, let's see, number 2, 4. Write the first four terms of the AP when the first term and the common difference are given as follows. So here clearly the first term is given to be A is equal to, they denote the first term as A, I denote the first term as A1. It is convenient for me. Okay. A1 is actually the standard notation in mathematics. Okay. So first term is A equal to half, or A1, and the common difference is minus 1 by 6. Okay, so let us determine how to, let us see how to find out um, the AP. So what is the first term here? First term is equal to A1 is equal to half. Next, second term. Second term, if A1 is the first term, I told you second term is A1 plus D. So you will write equal to A2, equal to A1 plus D. The second term A2 is the first term plus the common difference. The first term half plus the common difference. You write it with the sign. And now you take the LCM. This is half minus 1 by 6. So you get 3 minus 1, 2 by 6, which is 1/3. So your second term is 1/3. What about, how about the third term? Third term. Third term is A1 plus 2D. If you see in this formula here that I have given, third term is A1 plus 2D. So this is half plus 2D. This is half minus 1/3. Now you take the LCM, 3 minus 2, which is 1 by 6. Fourth term similarly is A1 plus, let's write this as A3. Third term is A3. Fourth term is A4. A1 plus 3D, which is half plus 3 times D. So half minus half, which is 0. So the fourth term is 0. So they have asked only till 4 terms. So therefore, the first 4 terms of the AP are, what are the first 4 terms? The first term is half, Second term is 1/3, half, 1/3. Third term is 1/6, and the fourth term is 0. That's it. Okay, so two things. First of all, the set of numbers may be given. You have to determine the first term and the common difference. Or the second option is that the first term and the common difference can be given. You have to determine the AP. And this is how you determine. Okay, let us see the uh, number 3. Only these two are the most basic kind of problems that you must be aware of in AP in order to move on to your higher problems. Okay, so let us move on to number 3. 3 part 8. The question here is, which of the following list of numbers form an AP? Okay, so you have to determine whether this forms an AP or not. Okay, and if it forms an AP, if they form an AP, find the common difference and write the next 3 terms. Now, since GP has been excluded from your syllabus, things become a little easier, because earlier what we used to do was we used to check whether if it is not an AP, then we used to check whether it is a GP. Okay, and the testing for GP was a little tougher than AP. The test for AP is a little easy. So things have got a little easy now. So what is the given this thing? The given numbers are √2, √8, √18, √32, and so on. These are the given numbers. I prefer to put them within brackets. In the book, mostly they don't put within brackets, but I prefer to put them within brackets. The given numbers are these. Okay, you need to check whether this is an AP. So first term A1, √2. Second term A2 is √8. Third term A3 is √18. Let us now check A3, A1, A2 minus A1. A2 minus A1 is equal to √8 minus √2. In fact, let us write the fourth term also, since it is given. We'll check for this also. Fourth term is √32. So A2 minus A1 is now 8 is 2 √2. So from this you can take √2 common, you get 2 minus 1 is equal to √2. Next, A3 minus A2. A3 minus A2 is √18 minus √8. √18 is, if you convert it to a mixed third, it becomes 3 √2, right? Minus, and √8 becomes 2 √2. Now you take √2 common, you get 3 minus 2, which is again √2. Okay. So this is moving towards this. We can now say that it is an AP. But since fourth term is given, we'll check for the fourth term also, because sometimes what happens, first 3 terms they give an AP, and the fourth terms, in order to confuse you, they don't yeah, give that as give it as a different term. So let us check this also. A4 minus A3. A4 minus A3 is √32 minus, this is A4 obviously, √32 minus √18. And √32, if written in terms of mixed surds, what should it be? Should be 4 √2. And this is √18 is 2 √2. Okay. Hmm.
Sir, root 18 is 3 root.
√18 is 3 √2. Okay, fine. 3 √2. So this is √2, 4 minus 3, which is again √2. So what I see here is that A2 minus A1 is also √2. This is also √2. This is also √2. Now, therefore, now we can say that the given set of numbers Therefore, now I can say that root 2, root 8, root 18, root 8, root 18, root 32, and so on forms an AP. And what is the common difference? Common difference is D is equal to A2 minus A1 or A3 minus A2 or A4 minus A3, whatever you take, which is equal to root 2. Okay, and the first term here is A1 equal to root 2. That's it. Okay, so that is what. And let us now work out the next one also, 3 part 10, and that should be it for today. We'll move on to the problems tomorrow. You need to check whether this set of numbers is forms an AP. How do you check whether these numbers form an AP? Exactly in a similar manner. Okay, so this is 3 part 10. The given numbers are A, 2A plus 1, 3A plus 2, 4A plus 3, and so on. Okay, so consider this one as our A. A1 is our A. Second term A2 is 2A plus 1. Third term A3 is 3A plus 2. Fourth term is 4A plus 3, and so on. Okay, these are numbers that are given. Okay, now if you want to check whether it's an AP, you find out A2 minus A1. So this is 2A plus 1 minus A. It's 2A plus 1 minus A, which is A plus 1. Next, let's check A3 minus A2. 3A plus 2 minus 2A plus 1, which is 3A plus 2 minus 2A minus 1. Okay, this is again A plus 1. And finally, A4 minus E3. 4A plus 3 minus 3A plus 2. 4A plus 3 minus 3A minus 2 again comes to A plus 1. So therefore, this A, 2A plus 1, 3A plus 2, 4A plus 3 forms an AP with first term equal to first term A1 is equal to A, and common difference D is equal to, let's say, A2 minus A1, or you can take A3 minus A2 is equal to A plus 1. That's it. Okay, so I stop here for today.